Alright, so we are gonna start all of your derivative rules. Here's my pep talk for this. It is very cut and dry and very boring. There is not a, what does it all mean? There is not a story attached to anything. There aren't word problems. Some people actually really like this. Go ahead and close this. It's just very much here, do these math problems, memorize these rules and make sure that you can use them, okay? So if that's kind of like your thing, like, oh, I just wanna sit and do a bunch of math problems, that's what this is. If you like more context and like a story and things, that's kind of not what this is. That first piece of paper that I gave you, this is where we're gonna put all of our rules. It really doesn't matter where you put them, except for save this largest bubble for when we get to the trig. We're not doing that today, but the reason you want this one for the trig is how many trig functions are there? I want a specific number. So you want to save that one for the trig function so that you can fit all of them in there, okay? First rule, and the thing on the back of here, we're going to do that later in the unit. The reason I put it there is I don't like wasting paper and I don't like the back of something to be blank. So I just threw that on there, but we're going to do that a different day as well. Just hold on to it, okay? So first rule we're going to do is power rule. And we're also going to talk a little bit about notation. So you know you have different notation for a derivative. You have y prime and you have f prime of x and you have dy dx. Dy dx means derivative of y with respect to x. That's what that means, dy dx, y with respect to x. When you just see this, and there's not a y, that's more of a verb. It's instructions that mean take a derivative of this thing, okay? So dy dx is more a noun, that's more a verb. So for power rule, this means take the derivative of, and we're going to put x to the nth. So how does power rule work? What are we going to do with the power? Yeah, multiply it down, so it'll be n, and then you keep the variable x, and then your power, what happens to it? N minus what? You subtract 1. Be really careful because if it's negative and you subtract 1, it's going to become more negative, okay? So we're going to go over to the practice problems. What we're going to do is do a rule, practice it. Do a rule, practice it. We'll do a brain break somewhere in between. Again, try not to fall asleep. It is cut and dry and kind of boring, and you'll have to do a bunch of problems, but we'll see how this goes, okay? It might go quick, and we'll see where the problems are. All right, so for number 1, let's all just do that and make sure we get the same thing. Just turn to your partner and be like, I got this. What did you get? Okay? Yeah. Perfect. You're going to do nothing at all. Your notes, no, on a test, please put it. Okay. That was a really good question I heard over here. Can I say that for everybody? Yeah. Is do you need to put the f prime? On your notes belong to you. I'm not going to take them back from you. The point of this is for you to have something to look back at to study from. So if you don't put it, fine, it's yours. On a test, it's extra important that you write f prime because we're eventually going to get to the point where we have f prime and we have f double prime, which I had a class one year that called it prime prime, and I thought that was really funny, and so like now that's kind of stuck in my head. But when you have f prime, and f double prime, it's really important you label them because they're different, okay? But for notes, you can kind of do what you want. But did you all get that? Yeah. Perfect. All right, for this one, let's have a brief conversation. Your derivative of square root is 1/2 square root. I just always tell everybody, and I tell my AB classes this too, just memorize that one. It is just easier to have that in your back pocket rather than dealing with the power of a half and then the power of a negative a half and the fractions and the negative signs everywhere. Just if you could get on board with me, 1/2 square root, cool? You'll just, your life will be so much easier. When we get to chain rule and you just know that, it'll be so much better. Like just 1/2 square root, okay? Now this one, we are going to have to deal with a negative. I can rewrite this as 3x to the what? -5. Cool. Now we're going to do the derivative, and we're just going to be careful because there's a negative. It would be -15x to the what? -6. Perfect. And then you have to fix that. Perfect. The negative puts it back in the denominator. So your final answer is negative 15 over x to the 6. Cool. And then this, since there's not a variable at all, it's just a constant, what's your 0? Beautiful. That's power rule. All good? Not going to labor over that. Let's go back to our rules. We are doing excellent on time. You guys are doing very well here. All right, let me just throw it out there and ask you, what's the next rule? We did power rule, product rule. Good. Product means you're doing what? Multiplying. So we're going to put d dx. Again, that's instructions that mean take a derivative with respect to x. All right? So it's derivative if you have a product, f of x times g of x. On the AP exam, they could be P of X and Q of X, or R of X and S of X. You have to just not let the letter bother you. Go ahead. Put what?
What's butter minus? Okay.
Well, yeah. Let me just go ahead. Now, so don't call them F and G, because again, on the AP exam, they could use any letter of the alphabet they want. So in your mind, you don't want to call them F and G. You want to call them the first thing and the second thing, or the first function, I should say, and the second function. The first and the second, on board? Not F and G, because they might not be F and G. So your product rule is the first function, derivative of the second function, plus, and then does anyone remember what comes next?
G.
Yep, G, the second function, times F prime. Hey, that's cool. What if I put it in the other order? Fine, you have flexibility here because it's addition. Whatever order you add in, it means the exact same thing. So this is how I'm always going to do it for consistency. First times derivative of the second plus second times derivative of the first. If you see it like written out officially in a textbook or something, that's what it's going to look like. So that's what I'm going to go with. You can be flexible in the order you do stuff. Okay? I didn't hear that, and I'm going to just pretend I didn't. All right, so number 5. Hardest part is figuring out which rule you want, right? Do you see how this is a first function and this is a second function? Like, do you see? Because it's one of those things where I can't walk up to you and shake you and be like, do you see it? You know, I think like you have to be able to identify, right? So we're going to put the first function. Hey, Miss Cool, looks like you just copied that. Sure did. Rewrote what's there. Don't do a copy error. Those are the worst, right? Now, derivative of the second. You're going to bring that negative 2 down, and it's going to drop to a negative 3. And then what else do I need for my derivative of that second function? Plus 5. Beautiful. Right? So first function, derivative of the second, plus the second function, like literally just copy it. And then derivative of the first, which would be what? 3x squared plus 7. Perfect.
We have brackets around.
Let's try number 7. The product rule is not any more complicated. I just threw a 4th root in there, okay? So we're going to get through that together. We're not scared of fractions, okay? All right, so it's going to be the first function, x cubed plus 2x, and then derivative of the second. So real quick, square root means x to the 1/2. Cube root means x to the 1/3. So this is x to the 1/4. Perfect. Good. First step done. So when you do power rule with that, you're going to bring the 1/4 down. Your x is there, and you subtract 1. So here's the $1 million question to the whole thing. You want a 4th minus 1. It will be negative. Negative 3 over 4. Perfect. And then actually that's it. Why are we done with that derivative? Yeah, the other's one's a constant, all right? So first derivative of the second plus the second function, like, hey, Miss Cole, looks like you just copied it. Sure did. And then derivative of the first, that would be 3x squared plus 2. Nice. This is going real good. Yeah, good. Yeah. Nope. Now, in a multiple choice scenario, they may ask you to find f prime of 1, you would have to plug in 1 and simplify that down. But typically they ask you to plug in 1 or 0, and it's something very simple that you can do without a calculator. You gonna make it? Okay. Oh, we're ready for another rule. Go back to your rule sheet. Quotient rule, perfect.
Isn't there some over here?
It's the same thing where it's over.
Sort of. Why don't you just let me lead the expedition? That's my job. Let me earn my money, okay? So quotient means you're dividing. It's derivative of one function divided by another. Again, same pep talk I gave about product rule. Do not in your mind call them F and G. On the AP exam, they could call them A and B. So you don't want to get hung up on the letter. Product rule, we call them the first and the second. For quotient rule, you want to call them the numerator and the denominator. With me? If you remember how this starts and you get the ball rolling, you will likely get the rest of it. You have to remember that it starts with the denominator. So it is the denominator times derivative of the numerator. And this is the important part. Minus numerator derivative of the denominator over the denominator squared. And I'm going to give that another hug, another parenthesis around it. So it's kind of like product rule, except when I said product rule, I was like, oh, you have some leniency. You can kind of write it in the other order. Can you do this one in the other order? No, subtraction doesn't work like that. So you have to do this one that way. Here's the most common mistake I see with this. And can you all please listen to me? Because if anybody does this, I'm going to lose my mind. Is people who cancel out one of these g of x's. No cancellation without factorization. If you didn't factor, you can't cancel. Please don't cancel those. Okay? Actually, just do nothing. Can we just not do anything? Just do nothing. Be lazier. Okay? All right. We don't need to do every single one of these. Let's do 8 and 10. We'll skip number 9. Okay? So for this one, you're going to start with the denominator.
Yeah.
You can lift the desk and stand like I'm standing. That's what I do. That's why I do.
Oh, I am in.
Oh, okay. Oh, okay, got it. All right. This is a very disjointed video, but you're all here. So, all right. Denominator, derivative of the numerator, minus numerator, derivative of the denominator, which is 2, over denominator squared. Let's skip number 9. We'll just do number 10. Again, with notes, you'll find I do this a lot. I put way more on here than we need, so you can have it for extra practice, and then I'll like skip a few. All right, again, where does it start? Square root denominator. Again, if you get the party started, like if you get the ball rolling, you will likely get the rest of it because there's sort of nowhere else for you to go. All right, times derivative of the, ooh, what is the derivative of x plus 5?
0. Wait, 1.
It's 1. I suggest you write the 1. I've been doing this for decades, plural, bless you. And I still write the 1. I feel like sometimes at this level, people feel embarrassed that they write things like, oh, I shouldn't have to. No, that's literally your brain working. Those are literally your thoughts. I write it, okay? Minus, and then what will come next in our pattern? Good, x plus 5. Okay, let's see who's paying attention. 1 over 2 square root. Good job, guys. Perfect. You're on board with me. Yeah, good. Let me finish this one and I will turn back to that one. Now it's over denominator squared. Now if you take square root of x and you square it, it's just x. Now let me flip back a page and answer that question. So that was not a square root, it was a 4th root, so it does not follow the same pattern. That 1 over 2 square root is only for a square root. If you have a 3rd root or a 4th root or a 5th root or any other root, it doesn't follow that. Yeah, so but that's a good question. It's only for square roots. All right, now these have some other directions in them. You know what, we can probably, let's do the equation one. What things do you need in order to write an equation? There's 2 things you need. A point and a slope. So let's go ahead and set it up blank. We need a point and a slope. What's the x part of our point? -1, good. How do you get the y part? Plug it in. What's that going to be? -6 over 4. So -3/2. Slope comes from the derivative. So here's where we have to find the derivative. What rule is this? Quotient. All right, it's going to be denominator, derivative of the numerator, minus, sorry. What will come next? 6x, the numerator. Derivative of the denominator, weirdly, is also 6x, but that's just, how numbers work sometimes. No. They're just there. They're just multiplying. Yeah, you'd have to have a fraction to cancel out. All right, and then over the denominator squared. Now you're going to plug in -1 to get your slope. So let's see. This first part would be 4 times 6, so 24, minus, would that be 36, over 4 squared, so 16. So -12 over 16. So what is that, -3/4?
Yeah.
If it's on the free response part, though, you don't have to simplify it. No, you have to plug in the number, but once you get it to numbers, you can leave it like that. However, if you have to go to a next step, it helps if you simplify it. All right, now I got to write the answer. Y minus what one of these numbers? Yeah, now it would be minus negative, so plus 3/2 equals slope. Perfect. Parentheses.
X minus
It will be plus, but it's going to be the 1. Cool. I threw this on here just to make sure you know what a higher order derivative is. All right. If we find our first derivative, that's going to be what? 18x squared plus 4x. Cool. And then prime would be 36x plus 4. Now, when you get above that, you can just put a 3, which would be 36. And your fourth derivative would be 0. And every derivative after that would also be 0. I just threw that. Do you know what higher order derivatives are? You just do it again. I was just checking. Okay. And then I think I put chain rule on here too. Is that, yep, we're going to do chain rule. So go back to your little bubble sheet. This is our last one we're going to do. Do you remember chain rule?
Yeah.
I can work with sort of. Like when I say chain rule, you're like, oh yeah, that was a thing. I've heard that before. So chain rule is when you're taking a derivative of a composite function. So like f of g of x. It's not a product. It's not f of x times g of x. It's like f got hungry and ate g is what happened. It's f of g of x. You know what I always think of? Did you ever watch cartoon when you were little? Or I don't know if cartoons are like this nowadays. But did you ever see a cartoon where like a small fish is swimming around and a medium fish comes and eats it, and then a bigger fish comes by and eats like. Yeah. I don't know, that's how chain rule works in my head. It's like you're nesting. They're like the nesting dog, those Russian dolls. That's the Norska dolls. They like nest inside of each other. Anyway, so you do the derivative of the outside. In products, we call them first and second. Quotient, you call them numerator and denominator. Chain rule, you call them outside and inside. So you do derivative of the outside. The inside stays the same, or I call that the guts of the problem. The guts stays the same. Just leave that alone. And then you chain on, I always put a little dot, the derivative of the insides. So it's outside, leave the guts alone, derivative of the insides. But like I was just saying, You could have 3 or 4 functions all nested inside of each other, and then you keep linking on to your chain rule. Okay, so let's give a couple of these a shot. Again, I might not do every single one on here. Let's at least we'll at least do like 2 or 3 of these. All right, your outside function for number 14 is the 5th power. The inside is the stuff in parentheses. So usually, like, chain rule is going to have parentheses. You're going to have stuff that's inside. So you're going to bring the 5 down, and it's going to drop to a 4. Do you see how I left a big old blank? The guts stays the same. So, hey, Miss Cool, looks like you're just going to copy that. Sure am. Like, literally just copy it. The guts stays the same. You did the outside function. And then you're going to put a little chain rule dot, and you're going to chain on the derivative of those said guts, like the insides. So what's the derivative of just the stuff in the parentheses?
6x squared.
Yeah, 6x squared plus 4. Perfect. That's it. Okay. Maybe let's at least do number 15. This is going to be a chain rule, but it's also going to be one of the other ones. What other rule? Oh, good. Identifying it is half the battle, all right? The first function is x to the 4th. The second function is all that stuff in parentheses cubed. All right, so stick with me here. Product rule starts with the first thing, the first function.
Wait, don't we have chain rule?
We will. I'm just not there yet. Your brain is ahead of me. I will, just hold on. So the first function, which is just x to the 4th. Now, derivative of the second. You're going to bring the 3 down, drop it to a 2. Do you see how I just left a blank? All right, the guts stays the same. So just copy 3x plus 1, put a little chain rule dot, and you're going to chain on the derivative of what was in those parentheses, which would just be 3. Good job. Can I recap what we did so far? I'm going to make sure you're with me. This is the first function, derivative of the second. It was long because it involved a chain rule. Plus, now in our product rule, what comes next? I don't do it in that order. 3x plus 1 cubed, the second function, times derivative of the first. I'm going to just talk through a couple of the other ones. This would be both a chain rule and a what? It would be a chain rule and quotient rule. And so would this one. It would be a chain rule and a quotient rule. We already did an equation, so I think that's okay. Let's just do, I want to do one on the calculator, and then I want to do a couple using the table. Let me get out of full screen. Oh, you know what? I'm not in full screen. So that I can get the calculator up here. Can you guys all just look real quick? I'm going to go to my Desmos. All right, can you guys look up here? I think you know how to do this, but I just want to extra make sure. Read number 19. We want instantaneous rate of change. What does that mean? Slope derivative. I got both answers I wanted. Just watch me type this. Do you see how I'm just typing the function? It's your job to make sure I don't mess up. Sometimes I do it on purpose to make sure everybody is paying attention. There. Do you see how I typed it? Did I type it correctly? Okay. Now I'm going to come down to the next box, and I'm going to type f prime, which is just an apostrophe, of what number do we want this? 7. Whoever said x, I don't know who that was, but I just want to clarify. It won't find a derivative. It will only find a derivative at a value. Do you get what I'm saying? If you type f prime of x, it won't do that. It'll graph it, but it won't tell you what the answer is. Okay. So what we're going to write on our paper is 856,829. And how many decimal points do we need? 3. I am only going to truncate the first 3 that you see. Okay. How do I stop sharing here? I want to stop sharing. There we go. All right, first three that you see. I don't remember who this was, and if it was you, I'm so not picking on you, but I'm just remembering this, so I want to make sure everybody knows. We do not do significant figures in here.
Thank God.
Three or more. You can put as many as you want, but at least three. Okay. Then we'll just do a couple of these from the table. We'll do the even ones. We'll do 20 and 22. Which rule is this? Product. You have to do two things, and you just can't be lazy. You have to write the rule. On the AP exam, and this will be on here, it's 2 points. You get a point for writing the rule, and then you get a point for plugging in the numbers.
So that's what that is.
So 2 points. Now listen again to what I'm going to say. Do not write what I'm about to write. If you put an equal sign and then start plugging in numbers, that is what's called a linkage error. You are linking together two things that are not equal. Do you understand what I'm saying? This is with X, and then you want to plug in actual numbers. So just go down to the next line and start plugging them in. Now this is to see who can read a table. Go ahead. Can you just talk a little louder for me?
I have a question about writing it on these.
Yes.
So do you have to write all of that out, or can you just specify that you're using the product for?
No, it's notation. They won't take words, they want notation. It's kind of like with continuity, you have to use limit notation. They won't accept words like graph approaches this, they want notation. So I know that's not the answer you wanted, but that's what. I'm Miss Cole. That's what we're gonna focus on. All right, so we're gonna see who can read a table. What are we plugging in? 4? What's f of 4? Can you find that? 2. Good job. G prime of 4. Perfect. Plus G of 4 is 5, and f prime of 4 is 8. Actually, I changed my mind. We're gonna do 23. Because instead of f of g, it's g of f. You see that? You can't let the letters bother you, all right? If you look at 23, oh, and should you simplify this? No, because if you accidentally mess it up, guess what? Wrong. If you have a correct answer and turn it into an incorrect answer, they won't give you the points. They'll mark it wrong, all right? Which one is the outside function? G, so it is going to be g prime. Leave the guts alone. So G prime of F, chain rule dot, and you're going to chain on what? F prime. Now, some of you are yelling it out, and that's totally fine. Let me get everybody there for this, though, because this one involves a little bit of me pointing at the table, because I don't have a better explanation than, hey, look, okay? What number are we plugging in? 6? Here's what we're going to do. We're going to find F of 6. Whatever that is, we're going to do G prime of that number. Ready? So what is f of 6? Look at the table. You see how that's 4? Here, you can even write yourself a note. This part came out to be 4. You can write yourself a note. That's your brain working. Those are your thoughts, all right? Now you're going to do G prime of 4. Can you find that in your table? G prime of 4. Does anybody see it? Yeah, -3. Cool. So you do the inside, we got 4, and then you do G prime of 4. And then, what are we plugging in? F prime of 6. Good. Okay, so find F prime of 6 is 1.